Beyond the edge of observable space, 14 billion light-years from everything we call home, the James Webb Space Telescope has discovered something that makes the impossible look ordinary. For 2 years, this technological marvel has been sending back images that don't just challenge our understanding of physics, they demolish it completely. What you're about to discover will fundamentally change how you perceive reality itself. The cosmos is not what we thought it was. It's far stranger, far more dangerous, and far more alive than anyone dared imagine. Let's begin. The universe is dying, and it's happening in 2 completely different ways at the same time. For nearly a century, astronomers believed they had figured out the cosmic expansion rate, how fast space itself stretches as the universe ages. The equations were elegant, the measurements seemed solid. Everything fit together like a perfectly crafted mechanism. Then James Webb looked at the universe with unprecedented clarity, and that mechanism exploded into chaos. The telescope confirmed humanity's worst nightmare. Space is expanding at wildly different rates depending on which direction you look. Imagine standing in a room where one wall races away from you at highway speed, while the opposite wall barely moves. This isn't just improbable, it's physically impossible according to every law we've established. Yet Webb's measurements leave no room for doubt. When astronomers measure cosmic expansion using nearby stellar landmarks called Cepheid variables, they get one number. When they calculate it using the ancient light from the Big Bang itself, the cosmic microwave background, they get a completely different value. The discrepancy isn't a rounding error. We're talking about a difference so vast it suggests that either our instruments are catastrophically flawed, or the universe operates on principles we haven't even imagined yet. Nobel laureate Adam Rees, who first detected this cosmic schism, stated it plainly. We've measured this from every conceivable angle. The contradiction is real. Either we fundamentally misunderstood how space itself works, or there's an invisible force operating on cosmic scales that we cannot detect. The scientific term for this crisis is the Hubble tension, but that clinical label masks the existential terror of what we're facing. Our entire cosmological framework might be built on false assumptions. After analysing over 2,500 Cepheid stars spanning 200 million light-years, the impossible remains impossible. Some regions of the universe are expanding 73 kilometers per second faster per megaparsec. Other regions expand at only 67 kilometers per second. This shouldn't just be unlikely, it should be forbidden by the laws of physics. Dark energy, that mysterious force that drives cosmic expansion, might not be a constant at all. It might be tearing reality apart in ways that vary from place to place, creating rifts in spacetime that could eventually shred the fabric of existence itself. Webb's precision has eliminated every possible source of error. The measurements are correct, which means our understanding of reality is catastrophically wrong. But this discovery was only the opening act of Webb's assault on everything we thought we knew about the cosmos. Floating in the primordial darkness of the early universe, astronomers have found 8 colossal galaxies that have no right to exist. These aren't just large star systems, they're fully mature galactic empires containing hundreds of billions of stars, existing when the universe was barely 600 million years old. To understand how impossible this is, imagine finding a 40-year-old oak tree in a forest that was planted yesterday. Astrophysicist Ivo Labbé was examining Webb's deep field images when he noticed several impossibly bright red smudges in regions of space that should have been essentially empty. Red light in deep space typically indicates extreme age, ancient light stretched by billions of years of cosmic expansion. But these objects weren't just ancient, they were blazingly luminous and structurally complex, combining characteristics that simply cannot coexist according to our models of galaxy formation. Each of these monster galaxies contained between 100 billion and 1 trillion stars. Our own Milky Way took over 13 billion years to accumulate roughly 200 billion stars. These ancient titans accomplished the same feat in a fraction of the time, forming complete galactic ecosystems while the universe was still in its cosmic infancy. The star formation rates required would be absolutely staggering, thousands of new stars igniting every single year for hundreds of millions of years. The team studying these objects has informally dubbed them universe impossibles, because they threaten to invalidate decades of theoretical work on cosmic structure formation. According to every simulation we've run, every model we've constructed, Matter in the early universe should have assembled slowly through gravitational attraction. Small clumps would merge into larger ones over eons, gradually building the cosmic architecture we see today. These 8 galaxies demolish that entire timeline. They suggest the early universe was capable of organizing matter with an efficiency and speed that makes our current physics look like medieval alchemy. The implications cascade outward like ripples from a stone dropped in still water. If galaxies could grow this massive this quickly, dark matter, that invisible scaffolding that shapes cosmic structure, must have been clumping together far more aggressively than we ever predicted. The invisible architecture of the universe might be far more dynamic and violent than we realized. Perhaps dark matter doesn't just passively provide gravitational wells for normal matter to fall into. Perhaps it actively drives rapid structure formation through mechanisms we haven't discovered yet. Dr. Joel Leher, one of the lead researchers, captured the magnitude of the problem. If even one of these galaxies turns out to be real as confirmed through spectroscopic analysis, we'll need to fundamentally rewrite the first chapter of cosmic history. If all 8 are real, we'll need to throw out the textbook entirely and start from scratch. Follow-up observations with Webb's spectroscopic instruments confirmed the worst. These galaxies are real, they exist, and they're forcing scientists to confront the possibility that the early universe operated according to rules that no longer apply today. But these impossible galaxies were just the first of many discoveries that would force humanity to question everything we thought we understood about cosmic evolution. Drifting through the cosmic void like ghosts from the universe's violent past, Webb has discovered dozens of supermassive black holes that exist in complete isolation. No galaxies surround them, no stars orbit them, just naked gravitational monsters containing tens of millions of solar masses wandering alone through the darkness. These objects shouldn't exist. They violate every theory of black hole formation we've developed. The first of these phantom holes, designated UHZ1, contains 40 million times the mass of our Sun, compressed into a region smaller than our solar system. It exists in the universe's childhood, just 470 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, which means waiting for the first generation of stars to form, live their brief but brilliant lives, and explode in supernovas that leave behind stellar corpses. That process should take at least 500 million years. UHZ1 formed before that process could even begin. Priyamvada Natarajan at Yale University, who helped identify this cosmic phantom, described it as the most significant black hole discovery in decades, because it forces us to confront formation mechanisms that sound more like science fiction than science. 3 theories attempt to explain these naked monsters, and each one is more disturbing than the last. The first theory proposes that some black holes form directly from the collapse of massive gas clouds without ever going through a stellar phase. Imagine a cloud of hydrogen so dense and massive that it simply collapses straight into a black hole, bypassing stars entirely. This requires conditions so extreme that they might only have existed in the universe's earliest moments. The second theory suggests that somehow black holes in the early universe fed on matter at rates far exceeding what physics should allow. They grew so rapidly, consuming gas and stars so voraciously that they reached supermassive status in a fraction of the expected time. Spectroscopic instruments confirmed the worst. These galaxies are real, they exist, and they're forcing scientists to confront the possibility that the early universe operated according to rules that no longer apply today. But these impossible galaxies were just the first of many discoveries that would force humanity to question everything we thought we understood about cosmic evolution. Drifting through the cosmic void like ghosts from the universe's violent past, Webb has discovered dozens of supermassive black holes that exist in complete isolation. No galaxies surround them, no stars orbit them, just naked gravitational monsters containing tens of millions of solar masses wandering alone through the darkness. These objects shouldn't exist. They violate every theory of black hole formation we've developed. The first of these phantom holes, designated UHZ1, contains 40 million times the mass of our Sun, compressed into a region smaller than our solar system. It exists in the universe's childhood, just 470 million years after the Big Bang. Traditional black hole formation requires the death of massive stars, which means waiting for the first generation of stars to form, live their brief but brilliant lives, and explode in supernovas that leave behind stellar corpses. That process should take at least 500 million years. UHZ1 formed before that process could even begin. Priyamvada Natarajan at Yale University, who helped identify this cosmic phantom, described it as the most significant black hole discovery in decades, because it forces us to confront formation mechanisms that sound more like science fiction than science. 3 theories attempt to explain these naked monsters, and each one is more disturbing than the last. The first theory proposes that some black holes form directly from the collapse of massive gas clouds without ever going through a stellar phase. Imagine a cloud of hydrogen so dense and massive that it simply collapses straight into a black hole, bypassing stars entirely. This requires conditions so extreme that they might only have existed in the universe's earliest moments. The second theory suggests that somehow black holes in the early universe fed on matter at rates far exceeding what physics should allow. They grew so rapidly, consuming gas and stars so voraciously that they reached supermassive status in a fraction of the expected time. This would require breaking what scientists call the Eddington limit, the maximum rate at which a black hole can consume matter before radiation pressure blows away its food supply. The third theory is the most unsettling of all. These phantom black holes might be primordial, formed in the first fraction of a second after the Big Bang itself, during violent quantum fluctuations in the fabric of space-time. If true, these objects predate stars, galaxies, planets, and every structure in the observable universe. They've been lurking in the cosmic darkness since the moment of creation, ancient beyond ancient, waiting 13 billion years for the universe to evolve enough for us to detect them. Webb has identified over 60 of these isolated supermassive black holes scattered throughout the early universe. They appear as tiny red dots in deep field images, each one a potential cosmic monster that defies explanation. They glow with the light of superheated matter spiraling toward their event horizons, but they have no galactic host to feed them. They're vampires without victims, monsters without prey. The existence of naked black holes fundamentally challenges our understanding of the relationship between galaxies and their central black holes. We've always assumed these structures grew together through a cosmic symbiosis, the black hole regulating star formation in its host galaxy, the galaxy providing matter to feed its central black hole. These phantom holes suggest that black holes might be more fundamental to cosmic structure than galaxies themselves. Perhaps black holes came first, and galaxies formed around them later. Perhaps the universe began with invisible monsters that shaped everything that came after. If these really are primordial black holes, they represent time capsules from the universe's first moment, objects that have witnessed the entire history of cosmic evolution from the inside of their event horizons. But these ancient phantoms weren't the only impossible black holes that Webb would discover. In direct violation of everything we thought we knew about cosmic history, James Webb has found evidence that supermassive black holes might have illuminated the universe before the first stars ever ignited. This inverts our entire understanding of the cosmic dark ages, that period between the Big Bang's afterglow and the formation of the first luminous objects. Professor Andrea Ferrara at the Scuola Normale Superiore in Pisa proposes a radical solution to the mystery of early supermassive black holes. What if black holes, not stars, were the universe's first light sources? What if primordial black holes formed in the chaotic first moments after creation were already lurking in the darkness when space was less than 100 million years old? The mechanism would work like this. In the first few seconds after the Big Bang, the universe was a seething cauldron of energy and matter undergoing violent quantum fluctuations. In regions where these fluctuations created extreme density variations, space itself might have collapsed directly into black holes without ever forming stars. These primordial monsters would have sat dormant in the darkness for hundreds of millions of years, essentially waiting for the universe to cool and evolve enough to provide them with food. When the first massive clouds of hydrogen gas finally formed, these ancient black holes would have begun feeding. As gas spiraled into their gravitational maws, it would heat to millions of degrees, emitting brilliant light across the electromagnetic spectrum. From a distance, this accretion radiation can appear almost identical to the light from stars. The universe's first illumination might have come not from nuclear fusion in stellar cores, but from gravitational destruction at black hole event horizons. Webb's observations support this disturbing scenario. Many of the brightest objects in the early universe appear point-like rather than extended, suggesting compact sources rather than distributed star formation. Their spectral signatures show characteristics consistent with superheated accretion disks rather than stellar populations. The universe's dawn might have been lit by cosmic destruction rather than stellar birth. If this theory is correct, it means primordial black holes had a head start of hundreds of millions of years, allowing them to reach enormous sizes before the first galaxies even began to coalesce around them. This would explain how supermassive black holes grew so massive so quickly. They didn't start from stellar remnants weighing a few solar masses. They started as primordial objects already containing thousands or millions of solar masses. But this scenario raises even more disturbing questions. If primordial black holes were common in the early universe, they might still be out there today. Some could be wandering through our own galaxy right now, invisible relics from the universe's violent birth that predate every star we can see. These ancient ghosts would be completely undetectable unless they happen to pass near enough to a star or gas cloud to create observable effects. The detection of primordial black holes lighting the early universe would also provide crucial insights into the physics of the Big Bang itself. These objects would carry information about density fluctuations and energy conditions in the universe's first moments, a time so extreme that our current physics cannot adequately describe what happened. They're message bottles from the moment of creation, if only we can learn to read what they're telling us. But Webb's surveys of these ancient light sources revealed something even stranger: cosmic collisions, creating physics that shouldn't be possible. Deep in the cosmos, two massive galaxies are locked in a slow-motion collision that's creating something unprecedented in the known universe. Astronomers call it the Infinity Galaxy because of its distinctive shape, two bright nuclei connected by glowing streams of gas that form a perfect figure-8 pattern. But this cosmic oddity's appearance is the least interesting thing about it. What makes the Infinity Galaxy truly impossible is the location of its supermassive black hole. In normal galaxy mergers, the central black holes from each galaxy spiral toward each other over millions of years, eventually either merging into a single massive object or flinging one black hole out of the system entirely through a violent gravitational slingshot. The Infinity Galaxy breaks all these rules. Its supermassive black hole, containing roughly 8 million solar masses, sits suspended directly between the two collidatal libactic nuclei, floating in a vast ocean of glowing hydrogen gas that's been stripped away from both galaxies during their cosmic crash. This positioning should be gravitationally unstable. The black hole should be pulled toward one nucleus or the other. It shouldn't be hovering in the middle, like a referee overseeing the galactic destruction. Peter Van Dokkum at Yale and Gabriel Brammer at the Cosmic Dawn Center discovered this system while examining Webb's deep field images. The distinctive figure-8 shape immediately caught their attention, but follow-up observations with radio telescopes revealed something far more significant. Intense radio emissions pinpoint a massive black hole exactly where gravitational physics says it cannot exist. The researchers believe they're witnessing something called direct collapse black hole formation happening in real time. Instead of forming from the death of massive stars, this black hole might have been born directly from the collapse of a massive gas cloud created during the galaxy collision itself. The process would work like a cosmic avalanche. When the two galaxies crashed together at speeds of millions of miles per hour, they created enormous tidal streams of gas flowing between their cores. Under exactly the right conditions, the right mass, density, and temperature, these gas streams can become so massive that they collapse directly into a black hole without ever forming stars first. It's gravitational collapse without the intermediate step of stellar evolution. This direct collapse mechanism solves one of Webb's most puzzling discoveries. The telescope has found supermassive black holes throughout the early universe that are far too massive for their age. If black holes can form directly from collapsing gas clouds rather than requiring stellar evolution first, they could reach supermassive status much more quickly, potentially within just a few million years rather than hundreds of millions. The Infinity Galaxy represents a real-time laboratory for studying this exotic formation process. The black hole appears to be actively feeding on gas flowing between the two colliding cores, growing larger as astronomers watch. Radio observations show intense energy emissions from exactly where theory predicts the black hole should be located. We're watching a monster being born, but the most disturbing aspect isn't what we're seeing now. It's what this discovery suggests about the universe's youth. If direct collapse black hole formation was common in the early cosmos, it means galaxy formation was accompanied by catastrophic events that could instantly create some of the most massive objects in the universe. The early universe might have been far more violent than we ever imagined, filled with colliding proto-galaxies, spawning black holes at an alarming rate. And that violence left behind not just wandering black holes, but entire orphaned worlds broadcasting signals we cannot explain. Drifting through the darkness of the Orion Nebula, over 540 rogue planets float untethered to any star. Each roughly the size of Jupiter, these cosmic orphans have been ejected from their original solar systems and now wander through the frozen void of interstellar space. What makes them truly bizarre is that many travel in pairs, binary planets orbiting each other at vast distances, while together they orbit nothing at all. Scientists call these paired wanderers Jupiter Mass Binary Objects, or JUMBOS. They challenge every theory of planet formation we've developed. Planets form in the disks of gas and dust surrounding young stars, slowly accumulating material through gravitational attraction until they reach their final size. The complex gravitational choreography required to create binary planets should be extraordinarily rare. Yet Webb has found dozens of these cosmic couples in just one stellar nursery. The mystery deepened dramatically when astronomers pointed radio telescopes at these paired planets and discovered something unprecedented. Several jumbos are emitting powerful radio signals with characteristics never before seen from planetary objects. These aren't the typical radio emissions you'd expect from worlds with magnetic fields interacting with charged particles from their parent stars, because these worlds have no parent stars. The radio signals operate at gigahertz frequencies, thousands of times higher than FM radio broadcasts. On Earth, emissions at these frequencies come from either technological sources or extremely energetic astronomical phenomena like pulsars and quasars. Finding them emanating from rogue planets suggests these worlds are experiencing physical processes that don't exist anywhere in our solar system. The radio emissions appear to be linked to the binary nature of these planets. When two massive objects orbit each other in the emptiness of interstellar space, they create complex gravitational interactions that can generate extraordinarily powerful magnetic fields and electrical currents. Think of it as cosmic friction on a scale we've never encountered. The jumbos are essentially giant dynamos, powered by their mutual orbital dance, converting gravitational energy into electromagnetic radiation. But the signals themselves remain deeply puzzling. Different binary pairs produce different radio signatures. Some emit steady streams of radio waves, while others produce sporadic bursts that follow no discernible pattern. Each jumbo pair has its own unique electromagnetic personality, as if they're individual entities rather than classes of similar objects. The implications are profoundly unsettling. If these orphaned worlds can generate radio signals this powerful, their magnetic fields might be orders of magnitude stronger than anything in our solar system. They could be creating space weather phenomena, magnetic storms, particle accelerations, electromagnetic disturbances that would be lethal to any spacecraft that wandered too close. Even more disturbing is what the sheer number of JUMBOs suggests about planetary system formation. If over 500 of these paired worlds exist in just one nebula, there could be billions scattered throughout our galaxy. Each represents a failed solar system, a cosmic tragedy where gravitational interactions during formation went catastrophically wrong and ejected planets into eternal night. These rogue worlds exist in perpetual darkness, forever separated from stellar warmth. Their only heat sources are the slow radioactive decay in their cores and the tidal forces generated by their orbital dance with their companions. They're cosmic refugees, wandering the galaxy for billions of years with no home and no destination. But as disturbing as these broadcasting orphans are, Webb discovered young star systems creating planets in ways that make the impossible look ordinary. In a star-forming region 5,500 light-years from Earth, James Webb has discovered a planetary system being born from the wrong materials. The protoplanetary disk surrounding the young star XUE1 contains almost no water, but is rich in carbon dioxide, exactly where Earth-like rocky planets should be forming. This finding shatters one of the most fundamental assumptions about how habitable worlds develop. Every model of planetary formation assumes that the regions around young stars where terrestrial planets form should be dominated by water ice and silicate minerals. Water is one of the most abundant molecules in the universe. Its presence in protoplanetary disks is considered essential for creating the chemical conditions that could eventually support life. The disk around XUE1 throws all these assumptions into chaos. When Webb examined this system using its near-infrared spectrograph, astronomers expected to see the familiar spectral fingerprint of water vapor mixed with other common compounds. Instead, they found a disk where carbon dioxide dominates the inner regions, the zone where rocky planets like Earth, Venus, and Mars typically form. Water is so scarce, it's barely detectable above background noise. This discovery challenges everything we understand about planetary chemistry. On Earth, water played a crucial role in creating our planet's geology, regulating its climate, and providing the medium in which life first emerged. A planet forming in the XUE1 system would develop under completely different chemical conditions, potentially creating types of worlds that have no analogue anywhere in our solar system. Two theories attempt to explain this bizarre chemistry, and both have profoundly unsettling implications. The first suggests that intense ultraviolet radiation, either from the young star itself or from massive nearby stars in the same stellar nursery, has essentially sterilized the disk. This radiation would break apart water molecules, drive the hydrogen away into space, and leave oxygen behind to combine with carbon into carbon dioxide. If this explanation is correct, it means ultraviolet radiation can fundamentally alter the chemical environment of planet-forming disks. Many potentially habitable worlds throughout the galaxy might never receive the chemical building blocks they need to support life as we know it. The universe could be filled with dry, carbon dioxide-rich worlds that formed under conditions hostile to the chemistry we associate with biology. The second theory is even more disturbing. The carbon dioxide dominance might result from unusual conditions in the dust grains that make up the planetary disk. Instead of being coated with water ice like dust grains in normal protoplanetary disks, these particles might be covered with carbon dioxide ice due to specific temperature and pressure conditions around this particular star. Either way, planetary formation can clearly follow pathways that astronomers never imagined. If the chemical environment of planet-forming disks can vary this dramatically, there might be entire classes of worlds out there operating according to geological and atmospheric processes we've never encountered. We might need to expand our definition of what constitutes a habitable planet to include chemical environments that seem alien by our standards. The XUE1 system represents a natural laboratory for studying alternative planetary formation pathways. As planets continue to coalesce from this unusual disk, they'll provide insights into how worlds develop when the basic chemical ingredients are fundamentally different from what we see in our own solar system. But the strange chemistry of planet formation was just one of many atmospheric mysteries Webb would uncover. The telescope's next target would reveal a world so hostile that it redefines what we think of as a planetary atmosphere. Orbiting so close to its star that a full year lasts just 17 Earth hours, the planet 55 Cancri E should be an airless rock. Surface temperatures exceed 4,400 degrees Fahrenheit, hot enough to vaporize iron and create lakes of molten lava across its dayside. By every rule of planetary physics, any atmosphere this world once possessed should have been stripped away billions of years ago by intense stellar radiation and solar wind. Yet James Webb has discovered something impossible. This hell planet not only has an atmosphere, but it's thick enough to redistribute heat and create weather. The discovery came through meticulous temperature measurements using Webb's mid-infrared instrument. When astronomers measured thermal emissions from the planet's dayside, they found it was significantly cooler than predicted. Something was blocking and redistributing the star's heat. That something could only be a substantial atmosphere, thick enough to transport energy from the scorching dayside to the frozen nightside through atmospheric circulation. This atmospheric circulation creates one of the most extreme weather systems ever discovered. Imagine supersonic winds howling at thousands of miles per hour, carrying vaporized rock and metal from day to night. The temperature difference between the two sides should exceed 3,000 degrees, but the atmosphere moderates this through convection currents operating under conditions no Earth-based laboratory could replicate. What makes this atmosphere truly impossible is its composition and source. The planet's atmosphere appears to be rich in carbon monoxide and carbon dioxide, gases that should be ripped away by the nearby star's intense radiation. This can't be a primordial atmosphere left over from formation, because stellar winds would have stripped away any original gases within millions of years. Instead, researchers believe they're witnessing a secondary atmosphere continuously regenerating from the planet's own interior. The intense heat and tidal forces from the nearby star are literally cooking the planet from within, causing carbon-rich materials deep underground to vaporize and escape through volcanic outgassing. The atmosphere is being constantly destroyed by radiation and constantly replenished by geology, a hellish cycle that sustains the impossible. Picture a world where the crust itself boils. Rock vapor rises from the surface, gets blown around the planet by supersonic winds, condenses on the night side, and rains back down as liquid metal and stone. The entire planet has become a massive distillation apparatus, operating under conditions that push the boundaries of what chemistry and physics allow. The existence of 55 Cancri E's atmosphere suggests that planets can maintain gases under far more extreme conditions than scientists previously thought possible. This has profound implications for our understanding of potentially habitable worlds. If atmospheres can survive in such hellish environments, they might also persist around planets we've written off as too hostile for life. But the hell planet's impossible atmosphere was merely preparation for Webb's next discovery, a visitor from another star system that challenges our understanding of time itself. Racing through our solar system at over 180,000 miles per hour, an interstellar comet designated 2I/Borisov carries secrets from long before Earth existed. It's approximately 4.5 billion years old, making it a contemporary of our Sun. But James Webb's detailed analysis revealed something that makes it truly extraordinary. Chemical signatures suggesting it formed in a solar system with drastically different conditions than our own, then survived that system's destruction and wandered the galaxy for eons before randomly passing through our cosmic neighborhood. Webb's near-infrared spectrograph revealed that the comet's coma, the cloud of gas and dust surrounding its nucleus, is dominated by carbon monoxide rather than the water vapor typical of comets from our solar system. This unusual composition provides a chemical fingerprint of the environment where it formed billions of years ago. The ratios of different molecules suggest formation temperatures and pressures unlike anything in our solar system's history. The comet is travelling on a hyperbolic trajectory, meaning it came from interstellar space, will swing past our Sun in a brief gravitational interaction and then return to the void between stars. It's not gravitationally bound to our solar system, it's just passing through, treating our entire planetary system as a temporary obstacle to navigate around. What makes this ancient messenger truly haunting is what it represents. 2I/Borisov formed around a star that lived and died billions of years ago. It might have survived its parent star's death, possibly a violent supernova explosion that destroyed its original solar system and sent countless objects tumbling into the galactic void. For billions of years it travelled through the cosmic deep, a frozen time capsule carrying chemical signatures from an ancient epoch. The fact that we're detecting it now raises disturbing questions about how many other ancient visitors might be passing through our solar system undetected. Statistical models suggest that dozens or even hundreds of these interstellar objects should be crossing our neighbourhood at any given moment. Each represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine. These are archaeological artifacts from stellar systems that existed when the universe was younger, carrying information about galactic conditions from epochs that no other objects can provide. They're cosmic refugees, wandering the galaxy with stories encoded in their chemistry that we're only beginning to learn how to read. But 2I/Borisov also serves as a preview of our own solar system's eventual fate. In about 5 billion years, when our sun begins to die and transforms into a red giant before collapsing into a white dwarf, objects from our world will be ejected into interstellar space. Comets, asteroids, perhaps even planets will become ancient wanderers that might puzzle astronomers in distant galaxies billions of years after Earth is gone. The ancient comet's visit was a reminder of cosmic timescales that dwarf human comprehension, but Webb surveys revealed objects even more mysterious than visitors from dead star systems. Scattered throughout Webb's deep field images, over 400 mysterious objects glow like crimson embers against the darkness of the early universe. Astronomers call them little red dots because they don't fit into any known category of cosmic object. Each appears as a tiny pinprick of red light, but their properties are so unusual that scientists are struggling to classify them. They're far brighter than they should be, given what we know about the universe's youth, and they're producing energy through processes we cannot identify. The mystery begins with their colour and luminosity. In astronomy, red light usually indicates either great distance, ancient light stretched by billions of years of cosmic expansion, or relatively cool temperatures. These objects are definitely ancient, existing when the universe was less than 1 billion years old. But they're also incredibly luminous, producing enormous amounts of energy despite their small apparent size. Using advanced imaging techniques and spectral energy distribution analysis, astronomers at multiple institutions have identified over 400 of these enigmatic objects in Webb's data. Each appears to be roughly the size of early galaxies, but produces far more light than galaxy formation models predict. If they're galaxies, they're unlike any that exist in the modern universe. The objects are so bright that they force scientists to reconsider how galaxies could have formed in the early cosmos. Traditional models assume the first galaxies grew slowly, accumulating matter through gravitational collapse over hundreds of millions of years. The little red dots suggest some process was creating massive luminous structures much more rapidly than current theories allow. But when astronomers attempt to determine exactly what's producing all this light, the answers make no sense. Some objects appear point-like, suggesting they might be powered by supermassive black holes, rather than distributed star formation. Others show evidence of extended structure, indicating they might be genuine galaxies undergoing extraordinarily rapid stellar birth. Many display characteristics of both simultaneously, which should be impossible. The most disturbing possibility is that these objects represent a completely unknown phase of cosmic evolution. During the universe's first billion years, physical conditions were drastically different from today. Matter was denser, dark matter interactions were more frequent, and the cosmic web of large-scale structure was still coalescing. Perhaps these extreme conditions allowed for types of object formation that simply cannot happen in the modern universe. Some little red dots show evidence of incredibly high-energy processes. They emit X-rays, ultraviolet radiation, and infrared light in patterns that suggest violent, chaotic energy production. Whatever powers these objects operates under conditions that push the boundaries of known physics. They are also distributed randomly throughout space, rather than clustered where early galaxy formation was expected to occur. This random distribution suggests they might represent a fundamental property of the early universe, rather than rare anomalies. Dr. Juna Kollmeyer at the Carnegie Observatories, who is leading one of the research teams, stated, "Even if only a fraction of these objects turn out to be what they appear to be, we'll need to completely revise our understanding of how structure formed in the early universe. They're not just unexpected, they're impossible according to our current models." The sheer number of mysterious objects Webb has found suggests our understanding of cosmic evolution during the universe's youth is fundamentally incomplete. The little red dots might be the most significant challenge to cosmology that the telescope has discovered, but their mystery pales in comparison to what Webb found when it examined the large-scale structure of the universe itself. In what may be James Webb's most reality-shattering discovery, astronomers have found evidence that galaxies separated by hundreds of millions of light-years are rotating in coordinated patterns. This cosmic choreography should be absolutely impossible. Galaxies that distant cannot have any gravitational or causal influence on each other, yet they're spinning in similar directions, as if participating in a cosmic dance coordinated by forces we cannot detect. The discovery emerged from observations of 1,043 galaxies captured during Webb's Advanced Deep Extragalactic Survey. When astronomers analysed the orientation and rotation patterns of these distant star systems using sophisticated computer algorithms, they found something that contradicts every principle of cosmology. Galaxies that should be completely independent of each other are rotating in statistically significant coordinated directions. Think of it like discovering that every windmill across an entire continent is turning in the same direction, even though there's no wind pattern that could coordinate their motion, and they're too far apart to influence each other mechanically. The galaxies are separated by distances so vast that light from one takes hundreds of millions of years to reach another. They're beyond each other's cosmic horizons, yet they're all participating in synchronized motion. Professor Lior Shamir, the computer scientist who led the analysis using advanced pattern recognition algorithms, identified two possible explanations for this phenomenon, and both fundamentally challenge our understanding of reality. The first explanation is that the universe itself was born rotating. If the Big Bang had angular momentum, a cosmic spin, it could have imprinted a preferred rotational direction on the structure of space-time itself. This imprint would affect how matter flows and how galaxies form, creating the coordinated spins Webb observed. This explanation aligns with a controversial theory called black hole cosmology, which proposes that our entire observable universe might be the interior of a massive black hole within a larger parent universe. If true, the rotational patterns Webb detected could be evidence of the parent black hole's spin, transmitted across cosmic scales through the curved geometry of space-time. The second explanation is even more disturbing. If the universe wasn't born rotating, then the coordinated galaxy spins indicate that existing theories about cosmic evolution are catastrophically incomplete. Some unknown force or field must be operating on scales larger than anything scientists have previously considered. Larger than galaxy clusters, larger than superclusters, perhaps operating across the entire observable universe. A rotating universe would have profoundly different physical properties than the static cosmos described by standard cosmological models. Space-time itself might have preferred directions, creating asymmetries in physical laws. The universe's ultimate fate might depend on its angular momentum. Dark energy's effect might vary depending on direction, causing space to expand faster in some directions than others. Perhaps most unsettling is what a rotating universe suggests about our place in the cosmic hierarchy. If our universe is spinning inside a larger structure, it means reality extends far beyond what we can observe. We might be living inside just one component of an incomprehensibly vast multiverse, where entire universes rotate like galaxies within some higher dimensional space we cannot comprehend. The coordinated galaxy rotations represent a fundamental challenge to our understanding of how cosmic structure forms. But this discovery was just the beginning of Webb's assault on conventional cosmology. What the telescope found next would force scientists to confront the possibility that we're living in a reality stranger than anyone imagined. Hidden among thousands of X-ray sources in a remote corner of space, James Webb identified a supermassive black hole that's violating fundamental laws of physics. The object, designated LID 568, is consuming matter at over 40 times its theoretical maximum feeding rate. This shouldn't just be unlikely, it should be physically impossible. Every black hole has what scientists call an Eddington limit, the maximum rate at which it can consume matter before the intense radiation from superheated gas blows away incoming material. It's like trying to drink from a fire hose. Beyond a certain flow rate, the pressure becomes so intense it prevents further consumption. LID 568 is somehow drinking from 40 fire hoses simultaneously, while defying the radiation pressure that should be choking off its food supply. The discovery required combining Webb's infrared sensitivity with data from NASA's Chandra X-ray Observatory. LID 568 was initially lost among thousands of bright X-ray sources, invisible to optical telescopes, but blazing in high-energy radiation. What makes this black hole's feeding frenzy truly disturbing is what it implies about growth rates in the early universe. At such extreme accretion rates, LID 568 could have gained most of its current mass, roughly 7 million solar masses, in a single sustained feeding episode lasting just a few million years. That's a cosmic eye blink. The object exists just 1.5 billion years after the Big Bang, when the universe was still in its infancy. For a black hole to reach supermassive status this quickly, while respecting normal feeding limits, would require starting from impossibly large seed masses, perhaps 10,000 solar masses or more. But we have no mechanism to create such massive seeds. LID 568's extreme feeding rate provides a potential solution. If black holes could feed this voraciously in the early universe, they could grow from stellar mass remnants to supermassive monsters in a fraction of the expected time. Dr. Haiwan Suh at the International Gemini Observatory, who led the discovery team, described what they found. The outflows we're detecting from this black hole are moving at extraordinary speeds, up to 5,000 kilometers per second. The sheer power output is staggering. This black hole is expelling more energy than many galaxies produce through all their stars combined. The physics of such extreme feeding remains poorly understood. The black hole must somehow be stabilizing the accretion process, despite radiation pressures that should blow away its food supply. Either LID 568 has developed some mechanism for controlling radiation pressure, perhaps through powerful magnetic fields that channel matter directly toward the event horizon, or the surrounding matter has exotic properties that allow it to resist being dispersed. Perhaps most disturbing is that LID 568 might not be unique. If one black hole can feed at 40 times the Eddington limit, others might be doing the same throughout the early universe. Webb might have discovered an entirely new class of superfeeders, black holes that gorge themselves during brief but intense feeding episodes, explaining how supermassive monsters reached their enormous sizes so quickly in cosmic history. The discovery suggests the early universe was far more chaotic and violent than modern astronomical observations would suggest. Instead of steady, gradual growth, cosmic structures might have developed through catastrophic episodes, feeding frenzies, collisions, and explosive events that shaped the universe during its youth in ways the calmer modern cosmos cannot replicate. But LID 568's impossible feeding was just one example of the bizarre phenomena Webb was uncovering. The telescope surveys were revealing that the cosmos's youth was a fundamentally different realm, operating according to rules that no longer apply today. Scattered throughout the early universe, James Webb has discovered what researchers are calling red monsters, massive galaxies that mysteriously shut down all star formation when they should have been at their most active. These cosmic giants contain hundreds of billions of stars, but show no signs of creating new ones. They're like vast cities where all construction suddenly halted for no apparent reason, leaving empty scaffolding and silent cranes across entire galactic neighborhoods. Dr. Mengyuan Zhao at the University of Geneva led the team that identified these dormant behemoths. Using Webb's spectroscopic instruments, they examined galaxies that formed between 1 and 3 billion years after the Big Bang, an era when the universe was rich with gas and dark matter, creating ideal conditions for explosive star formation. Most galaxies from this period should be blazing with newly formed stars, consuming available gas at furious rates. Instead, Webb found numerous massive galaxies in deep cosmic slumber. These systems contain stellar masses comparable to our Milky Way, between 100 billion and 1 trillion solar masses, but their star formation has completely ceased. Their light comes only from aging stars, with no new stellar nurseries to replace those that have died. The nickname red monsters comes from their colour and their challenge to cosmology. They appear red because their starlight comes from older, cooler stars rather than young, hot, blue ones. And they're monsters because they threaten to devour decades of theoretical work on galaxy evolution. Several theories attempt to explain why these galaxies fell into hibernation, and each challenges fundamental assumptions about how cosmic structures develop. The first suggests that supermassive black holes at their centres became so active that their energy output heated surrounding gas to temperatures too high for star formation, millions of degrees, far too hot for gas to collapse into stars. This process, called AGN feedback, can shut down star formation across entire galaxies. But the timing doesn't match. The red monsters show signs of having ceased star formation before their central black holes became active enough to cause such widespread heating. Something else must have triggered their dormancy. A second theory proposes something even more dramatic. These galaxies consumed their entire gas supply so rapidly during an initial burst of hyperactive star formation that they literally ran out of fuel. This explanation requires star formation rates hundreds of times higher than current models predict, rates so extreme they verge on the physically impossible. Yet the galaxy's stellar populations seem to require exactly this kind of formation history. The most disturbing possibility is that these galaxies encountered some process that doesn't exist in the modern universe. The early cosmos operated under radically different physical conditions: higher matter densities, more frequent galaxy interactions, different dark matter distributions, and perhaps exotic physical processes enabled by the universe's extreme youth. Dr. Carl Glazebrook at Swinburne University, who was not involved in the study but reviewed the findings, stated, "These red monsters are telling us that galaxy evolution in the early universe was nothing like the smooth, predictable process we see today. Something was capable of building enormous galaxies incredibly quickly, then shutting them down just as fast. We don't know what that something is. The existence of dormant galaxies in the early universe suggests that galaxy formation is far more chaotic and unpredictable than scientists believed. If massive galaxies could shut down their growth processes so early in cosmic history, it implies that the universe's youth was governed by violent, unstable processes that we're only beginning to recognize. But these sleeping giants were just one category of impossible objects Webb was uncovering. The telescope's next discovery would reveal atmospheric phenomena that defy every principle of planetary science. Drifting alone through the darkness between stars, a rogue planet designated SIMP J01365663 plus 0933473 has developed the most alien atmosphere ever discovered. This world doesn't orbit any star. It wanders freely through the galaxy, illuminated only by the faint glow of its own internal heat. Yet James Webb's atmospheric analysis revealed something that rewrites our understanding of what planetary atmospheres can be. This cosmic wanderer has a layered atmosphere where liquid iron literally falls from the sky. Near the surface, dense clouds of vaporized iron create weather systems unlike anything on Earth. These aren't wisps of water vapor. They're thick concentrations of metal vapor that condense into droplets and fall as iron rain during the planet's storms. Higher in the atmosphere, a completely separate cloud layer made of forsterite, a magnesium-rich silicate mineral commonly found in meteorites, creates an entirely different weather system. The interaction between these two cloud layers creates atmospheric dynamics that push the boundaries of what we thought possible. Webb's infrared observations revealed that both cloud layers are patchy and constantly changing, indicating active weather patterns driven by the planet's rotation and internal heat. The iron clouds appear to follow different circulation patterns than the silicate clouds above them, creating a three-dimensional atmospheric structure of stunning complexity. But the most mysterious aspect emerges from high above both cloud layers, where Webb detected what researchers call hotspots, regions of intense heat powered by radio auroras. These electromagnetic phenomena operate like Earth's northern lights, but at energy levels that would be instantly lethal to any known form of life. The radio auroras indicate that SIMP J01365663 plus 0933473 possesses an incredibly powerful magnetic field, far stronger than anything in our solar system. This magnetic dynamo interacts with charged particles in interstellar space, creating electrical currents that heat portions of the upper atmosphere to temperatures exceeding those in the metallic cloud layers below. Dr. Alison McCarthy, the graduate student leading the atmospheric analysis, described what they found. "We knew brown dwarfs and rogue planets could have exotic atmospheres, but this exceeds our wildest predictions. The planet has essentially created multiple independent weather systems stacked on top of each other. each operating according to different physical principles. Its atmospheric layering taken to an extreme we've never imagined. The existence of such complex atmospheric chemistry on a rogue planet raises profound questions. SIMP J01365663 plus 09333473 somehow developed and maintained this elaborate atmosphere while drifting through the frigid emptiness of interstellar space, far from any stellar energy source. This suggests rogue planets might be capable of supporting far more dynamic atmospheric processes than we previously imagined. If one wandering world can develop iron rain and silicate clouds powered by internal heat and magnetic fields, there might be millions of similar objects throughout the galaxy, each hosting unique atmospheric phenomena that we've never considered possible. The metallic rain world represents an entirely new category of planetary atmosphere that challenges our definitions of what constitutes a habitable or dynamic world. But even this alien atmosphere couldn't prepare astronomers for what Webb discovered next. A galaxy being torn apart by forces we can barely measure, swimming through the depths of space. A galaxy designated J0206 is being violently shredded by invisible forces. James Webb captured its image in stunning detail. A bright galactic core trailing long tentacles of gas and stars that stretch for hundreds of thousands of light years behind it. Astronomers call objects like this jellyfish galaxies because they appear to be swimming through space with streaming tendrils flowing behind them. But these tentacles aren't decorative. They're evidence of violent destruction happening in real time. A galaxy being torn apart as it moves through its environment. J0206 is undergoing ram pressure stripping as the galaxy moves through the hot, tenuous gas filling its galaxy cluster at speeds of several million miles per hour. It creates a cosmic headwind. This headwind is powerful enough to literally blow away portions of the galaxy's structure. Gas, dust, and even stars are being stripped from the galactic disk and left behind in long streaming tails. Imagine driving a convertible at highway speeds with loosely stacked cargo in the back seat. As you accelerate, items begin flying out, creating a trail of debris behind you. J0206 is losing parts of itself as it travels through space, leaving a trail of orphaned stars and gas clouds in its wake. Webb's infrared vision revealed the full extent of this cosmic violence. The galaxy's tentacles contain billions of stars that have been ripped away from their original homes. These stellar refugees now exist isolated from the galaxy's main body, slowly dispersing into the intergalactic void. Many will never return to their parent galaxy. They'll spend eternity drifting through the emptiness between galaxy clusters. But the most disturbing aspect isn't what J0206 is losing. It's what the stripping process reveals about its environment. The ram pressure required to create such extensive tentacles indicates the galaxy is moving through gas that's far denser and hotter than scientists expected. Temperatures in galaxy clusters can reach tens of millions of degrees, hot enough to strip electrons from atoms and create an ionized plasma that fills the space between galaxies. This suggests the cosmic web, the large-scale network of matter that connects galaxies across the universe, is more violent and turbulent than we realized. Instead of galaxies moving serenely through near-empty space, they're fighting their way through hostile environments that can literally tear them to pieces. Yet the destruction creates unexpected opportunities. As gas gets stripped from J0206 and compressed by ram pressure, it triggers bursts of star formation in the tentacles themselves. Webb's observations revealed dozens of bright blue stellar nurseries scattered throughout the trailing streams, young, massive stars being born in locations far from the galaxy's main disk. These stellar factories exist in gravitational isolation, billions of light-years from the structures that originally provided their raw materials. They're cosmic orphanages, creating new generations of stars from the debris of galactic destruction. The discovery of extensive jellyfish structures throughout Webb's surveys suggests that galactic shredding is far more common than astronomers previously believed. The universe might be filled with stellar refugees, stars and gas clouds torn from their parent galaxies and now adrift in the cosmic void. Each represents a small tragedy in the larger story of how galaxies evolve through violent interactions with their environments. But even this galactic violence pales in comparison to what Webb discovered about the fundamental nature of reality itself. In the most philosophically disturbing discovery Webb has made, evidence is mounting that space-time itself, the fundamental fabric of reality, becomes unstable under extreme conditions found throughout the cosmos. The telescope has detected gravitational anomalies, unexplained energy signatures, and structural irregularities, suggesting that the smooth, four-dimensional continuum described by Einstein's general relativity is more fragile than anyone imagined. The evidence comes from multiple independent observations. Gravitational lensing effects around some massive objects don't follow precise general relativistic predictions. They show small but statistically significant deviations that persist across multiple observations and independent analysis methods. These anomalies appear near supermassive black holes, in the cores of galaxy clusters, and around other regions where gravity becomes extreme. Dr. Elena Petrova at the Institute for Advanced Study, analysing Webb's gravitational lensing data, described what they're finding. It's like discovering that the laws of physics have fine print we never noticed before. Under normal conditions, space-time behaves exactly as general relativity predicts, but in extreme environments, near event horizons, in cluster cores, around colliding neutron stars, we're seeing signatures that suggest something additional is happening, something we don't have equations for yet. Quantum mechanics predicts that space-time at the smallest scales should be turbulent and chaotic, filled with virtual particles popping in and out of existence, creating a quantum foam beneath the smooth geometry we observe. This foam should exist only at unimaginably small scales, the Planck length, about 10 to the negative 35th meters, far smaller than anything we can directly observe. But Webb's observations suggest this quantum foam might bubble up to macroscopic scales under certain extreme conditions. The telescope has detected unexplained energy emissions from regions where quantum effects shouldn't be visible, including mysterious radiation from near black hole event horizons and anomalous heating in galaxy cluster cores that cannot be explained by known astrophysical processes. Perhaps most unsettling, Webb has identified several candidates for cosmic strings, hypothetical one-dimensional defects in spacetime that could have formed during the universe's earliest moments, when it underwent phase transitions as it cooled from the Big Bang. If cosmic strings exist, they represent fundamental scars in reality itself, places where spacetime is literally torn or folded in ways that violate our understanding of geometry. The telescope found gravitational lensing patterns that cannot be explained by any known distribution of matter or energy. Light from distant galaxies appears distorted in ways that match theoretical predictions for cosmic string lensing, long, linear distortions, rather than the circular or elliptical patterns created by massive objects like galaxies or black holes. If these observations are confirmed, they suggest the universe contains permanent vulnerabilities, structural defects left over from its violent birth that persist as weak points in the fabric of spacetime. Under the right conditions, these defects might even grow or interact, potentially affecting cosmic structure on the largest scale. Webb has also detected what might be vacuum decay events, regions where the quantum vacuum appears to transition to lower energy states through processes that release enormous amounts of energy. These transitions could represent fundamental phase changes in reality itself, where the underlying quantum fields that define physical laws shift into different configurations. The implications are staggering. If spacetime can become unstable under conditions that exist naturally throughout the cosmos, it raises questions about whether reality itself might be more temporary and contingent than we assume. The universe we observe might be just one possible configuration of quantum fields and spacetime geometry, a metastable state that could theoretically decay into something entirely different. The discovery of quantum effects operating on cosmic scales also suggests that the boundary between quantum mechanics and general relativity is more porous than theoretical physics predicts. These two pillar theories of modern physics, one governing the very small, the other governing the very large, might not be as separate as we thought. There might be intermediate regimes where both theories apply simultaneously, creating phenomena that neither can fully describe alone. But even these potential tears in reality couldn't prepare scientists for Webb's most reality-shattering discovery. evidence that challenges our most basic assumptions about where we are and what we're inside of. The coordinated rotation of distant galaxies, the impossible expansion rates, the ancient black holes that predate stars, all these anomalies point toward a single, terrifying conclusion. Our entire observable universe might be the interior of a massive black hole within a larger parent cosmos. This isn't science fiction, it's a serious cosmological theory called black hole cosmology, and James Webb's discoveries have provided the first observational evidence that might support it. The theory works like this. What we call the Big Bang wasn't the birth of all reality. It was our universe crossing the event horizon of a massive black hole in a higher dimensional parent universe. From our perspective inside, this crossing appears as cosmic expansion, space stretching, galaxies receding, the universe growing. But from the perspective of the parent universe, we're falling toward the black hole's singularity in a process that will take infinite time due to gravitational time dilation. This scenario elegantly explains several of Webb's most puzzling observations. The coordinated galaxy spins that shouldn't be possible? They result from our universe inheriting the angular momentum of the parent black hole. The entire observable cosmos is rotating because it formed from the interior of a spinning black hole. The galaxies aren't mysteriously coordinating their motion. They're all participating in a cosmic rotation that was imprinted on spacetime when our universe formed. The accelerating expansion that we attribute to dark energy? In black hole cosmology, this acceleration results from our continued fall toward the parent black hole's singularity. As we fall deeper, spacetime curvature increases, creating the illusion that expansion is speeding up when we're actually just experiencing increasingly severe gravitational distortion. The impossible expansion rate contradictions, different measurements giving different values. In black hole cosmology, these aren't contradictions at all. Different measurement techniques might be detecting different aspects of our motion through the curved spacetime inside the parent black hole. We're measuring the same phenomenon from multiple perspectives, each revealing a different facet of our complex trajectory toward the central singularity. Even Webb's discovery of primordial black holes that predate star formation fits this model perfectly. These ancient monsters could be smaller black holes that existed in the parent universe before we crossed the event horizon. They would appear in our cosmic history as primordial objects, ancient beyond ancient, because they literally are older than our universe, formed in the parent reality before we separated from it. Professor Nikodem Poplavsky at the University of New Haven has developed detailed mathematical models of black hole cosmology. His equations show that every black hole in our universe could contain an entire universe of its own, a nested cosmos with its own space, time, physical laws and evolutionary history. Our universe would be just one cell in an infinite fractal hierarchy of nested realities. The mathematics is surprisingly clean, Poplavsky explained in a recent lecture. When you properly account for torsion in Einstein's field equations, a term that's usually neglected, black holes naturally give birth to new universes on their other sides. From outside, it looks like a black hole. From inside, it looks like a Big Bang. They're the same object viewed from different perspectives. If this theory is correct, several profound implications follow. First, we are forever separated from the parent universe. Nothing that crosses an event horizon can return or send information back out. Every signal we transmit, every exploration we attempt, will remain trapped within our cosmic prison. We cannot communicate with or affect anything in the reality that contains us. Second, black holes throughout our universe, from stellar mass remnants to the supermassive monsters at galactic centers, might each contain entire universes. Every time a black hole forms in our cosmos, it might spark a new universe on the other side of its event horizon, complete with its own space, time, physical constants, and evolutionary trajectory. We might exist in an infinite multiverse of black hole universes, each one nested inside black holes in its parent universe, extending upward and downward through infinite levels of cosmic hierarchy. Third, our universe has an end date. Eventually, trillions of years from now, we'll reach the parent black hole's central singularity. What happens then remains unknown. Perhaps all matter and energy get compressed into an infinitely dense point. Perhaps quantum effects prevent singularities from actually forming, creating instead a bounce that initiates a new universe. Perhaps we emerge into yet another level of reality that we cannot currently imagine. The observational evidence supporting black hole cosmology is circumstantial but mounting. Webb's discovery of coordinated galaxy rotations, impossible early black holes, strange expansion rates, and potential cosmic strings all fit the model better than they fit standard cosmology. Each new observation from the telescope seems to provide another piece of a puzzle that, when assembled, reveals we might be living inside a cosmic matryoshka doll. But whether black hole cosmology is correct or not, one truth remains. James Webb has revealed a universe far stranger, far more complex, and far more alien than the orderly cosmos we thought we inhabited. The discoveries James Webb has made over its first years of operation don't just challenge specific theories about how galaxies form or black holes grow, they challenge our fundamental understanding of what kind of universe we live in, and what our place might be within it. Every assumption we've made about cosmic evolution has been shaken. We thought we understood the timeline: stars first, then black holes formed from stellar remnants, then galaxies assembled gradually over billions of years. Webb has shown us a universe where black holes might precede stars, where galaxies can form almost instantly, where the early cosmos operated according to rules that seem to violate the physics we observe today. We thought we understood expansion, space stretching uniformly in all directions at a rate we could measure and predict. Webb has revealed contradictory expansion rates that suggest either our measurements are fundamentally flawed, or space itself behaves in ways we haven't accounted for. The universe might be rotating. It might be accelerating non-uniformly. It might be falling into something larger that we cannot observe. We thought we understood our isolation, our universe as a complete, self-contained reality, with no outside or beyond. Webb's observations increasingly suggest we might inhabit just one level in an infinite hierarchy of nested universes, each one a black hole interior within a larger parent cosmos. If true, we're not just isolated in space, we're isolated in reality itself, forever separated from whatever larger existence contains us. The prevalence of cosmic violence Webb has revealed also affects our understanding of life's prospects in the universe. We're surrounded by wandering black holes, rogue planets broadcasting mysterious signals, stellar cannibalism, galaxies being shredded, and atmospheric chemistry hostile to the biological processes we understand. Our galaxy might be far more dangerous than we realized, filled with exotic objects and extreme environments that make the void seem welcoming by comparison. Yet these discoveries also inspire awe. The universe's capacity for surprise and complexity suggests that cosmic evolution is far richer and more diverse than our models predicted. If reality can produce impossible galaxies, naked black holes, and atmospheres of falling iron, it might also be capable of creating forms of life and intelligence that operate according to principles we haven't discovered. The cosmos might be filled with wonders we lack even the concepts to imagine. The rapid pace of discovery has also revealed how much remains unknown. Despite centuries of astronomical progress, Webb's first few years have uncovered phenomena that require completely rewriting our understanding of cosmic evolution. If we've been this wrong about fundamental processes, what else have we missed? What other impossibilities await discovery? Webb has essentially revealed that we're cosmic children, fumbling with equations and observations while trying to understand a universe that operates on principles we're only beginning to glimpse. Every strange object the telescope discovers, every impossible phenomenon it reveals, represents an opportunity to expand our understanding of what's possible in a cosmos that clearly delights in violating expectations. Perhaps most importantly, Webb's discoveries remind us that the universe doesn't owe us comprehensibility. Reality operates according to its own logic, following principles that might be fundamentally alien to human intuition. The cosmos exists independently of our understanding. It will continue operating according to its actual laws whether we figure them out or not. Our survival and success as a species depends on our ability to adapt our understanding to match reality as it actually exists, rather than as we wish it were. We must be willing to abandon cherished theories when observations contradict them. We must remain humble before the vast complexity of existence. we must accept that some questions might have answers we cannot grasp with our current conceptual frameworks. The universe James Webb has revealed is strange, violent, and often incomprehensible. It operates on timescales that dwarf human existence, on size scales that make galaxies look like dust motes, according to physical principles that push our mathematics to its limits and beyond. But it's also the only reality we have. This strange, impossible, magnificent cosmos is our home. Understanding it, no matter how disturbing that understanding might be, represents our best hope for navigating the cosmic future that awaits. The universe doesn't care whether we understand it, but we care, and that caring, that desperate need to comprehend our place in the vast machinery of existence, might be the most human thing about us. James Webb has pulled back the curtain on reality. What we've seen behind it is more alien than we imagined. The question now is whether we have the courage to keep looking, knowing that each new discovery might further shatter our cosmic confidence. The telescope continues its survey of deep space, peering into regions of space-time that have never been observed before. What other impossibilities await? The universe is vast, it is ancient, it is strange beyond our wildest imaginings, and we have only just begun to see what it truly is.